Let's talk about row and column transformations. So let's say we have a matrix 1, 2, 3, 4. Now in this matrix, these two elements comprise a row and these are the column elements. Likewise, these two elements also comprise a row and these elements comprise a column. So in general in this matrix we have got two rows, row 1 I'll call this and row 2, and this is column 1 and column 2. Now we are going to talk about first row transformation and then column transformation. So sometimes while solving problems we need to transform the rows. We are going to call the row by using the alphabet capital R and the column by using the alphabet capital C. Now let us see what are all the transformations which are available for us. So we can interchange two rows. So this means I am going to interchange row 1 with row 2. So if this is my matrix 1, 2, 3, 4, then if I apply the transformation row 1, 2, okay, then this will give me a new matrix 3, 4 and 1, 2. So what have I done? I have interchanged the first row with the second row. Then what else can I do? I can add the elements of one row with the other row. So let's say I decide to add two rows, R1 plus R2. Now remember one thing, whenever we are adding like this or even subtracting or whatever other operation we are performing, which we will see, the first row which is mentioned undergoes a change, right? So the convention is to write this as R1 plus R2 is equal to R1 dash. So we are adding the elements of the first row to the second row. So this will give us 3 plus 1, that is 4, 4 plus 2, that is 6, okay, and the second row remains as it is. So now we are having a new matrix which is 4, 1, 6, 2. Likewise, we can also subtract. So R1 minus R2. Now remember, this is the row which is changing. So the row which is changing is R1. So I am going to write this as R1 dash. And now I will continue the transform from this matrix itself. So I am subtracting the elements of the second row from the elements in the first row. So 4 minus 1 will give me 3. 6 minus 2 will give me 4. And the second row remains as it is. So far what we have seen? We have seen interchange of one row with the other row, right? Then we have seen addition of the elements of one row with the other row. Then we have seen subtraction of elements of one row from the other row. And this is what we are getting. Okay. Now we will continue with some more transformations. So let me again take into consideration the matrix 1, 2, 3, 4. So you know now these are the rows and these are the columns. So this is a row, this is a column, this is a column. So R1, R2, this is C1 and this is C2. So we just now saw the interchange of two rows. Then we saw the addition of two rows. We saw the subtraction of two rows. Now let us see the scalar multiplication of one row. This means that we are going to multiply one row with a scalar. So supposing I decide that I multiply the first row with the scalar 2. So what will happen? I have to multiply each element of the matrix with 2. So here 1, 2. So this will give me 2, 4 and this will remain as it is. Remember what I told you? This is the one that is changing. So R1 dash is equal to 2R1. So we are getting a new matrix and this is the scalar multiplication. Now what we can do is we can also combine the scalar multiplication with a addition or a subtraction. So let us say I decide to perform an operation where I say R1 plus 2R2. Now in this case R1 is changing. So again I will write this as R1 dash. And now we are talking about multiplying the second row with 2 and adding to the elements of the first row. So multiplying the second row elements with 2 is going to give me 2 3s are 6 plus this 2. So R1 is changing. So 6 plus 2 8. And over here we are going to multiply 4 by 2. So this is 8 plus 4 and that gives me 12. And the second row remains as it is. Right? So here we have combined the addition operation along with the scalar multiplication. Now we can also divide a certain row or column with a scalar. So here we have the first row 8 and 12. So what I can do is I can divide the elements of the first row with 2. So I'll call this as 1 by 2 R1, which is again going to give me a new R1 which I'll call as R1 dash. And now since I've divided these elements by 2, this will give me what? 8 divided by 2, 4. 12 divided by 2, that is 6, and 3, 4. So in this way we have seen different types of row transformations. So just a brief recap. Which transformations have we seen? First of all, interchange, right? Then we have seen addition and subtraction, and remember whatever we write first, the first row, that is changing, so R1 dash. Then we have seen multiplication by a scalar, so in general I can just say K R1, that is again R1 dash. Then we have also seen combination of multiplication or division by a scalar with the addition or subtraction. So we can write R1 plus or minus K times R2, and this is going to give me R1 dash. In the same exact same way, we can also perform column operations. So I would like you to try out those column operations. So when we are talking about column, we are going to use the alphabet capital C. So we will have C12, then we can have C1 plus or minus C2, which is going to give us a new C1, or we can multiply the column with a scalar, or we can combine the operation as C1 plus or minus K times C2, and this is again going to give us a new C1. So what I'd like you to do is take any random matrix of any order and try out all these operations. Thank you.